My name is Ibrahim Ali Aliu from the Department of Business Administration, University of Abuja. I'm here to take the course titled Business Mathematics 1, which is BOS 103. But I would like to begin in the name of God, the most gracious, the most merciful. The course, in conformity with the ODL module as sanctioned by NUC, will begin our study session 1, which is titled Indices. And you can see we will look into the meaning of indices, laws of indices, combination of various laws. We'll look at exponential equations. Then we'll move into theory of logarithm, laws of logarithm, applications of laws of logarithm to business and commerce and economic situation, because the emphasis of this course is to understand the basic mathematical tools, models, and their application. I repeat, students, their application is of paramount to us. We are not concerned with the pure mathematical aspect, but rather we are concerned with the application of those models, those theories, those functions, and how they can help to aid managerial decision making. As you can see, the assessment is basically designed into the TMAs. Your continuing assessment will be in form of what we call tutor mark assignment, which you also expect to submit on our LMS platform. Also, we have the first TMA, we have the second TMA, and we have the examination, which is 70 marks in total, while the TMA split it into 10 and 15, which result in 25 marks. So we have overall marks of what? 100. Now, the study session 1 begins with meaning of indices. When we say indices, we mean it's a system of shortening or abbreviating product of numbers of equal bases. When we say base, we mean a number that is raised to power an exponent. Now, the question is, what is an exponent? Student, if you may journey with me, let me indicate something on the board so that you will understand what I mean by indices. Whenever I write any expression, let's say 4 raised to power 3, this is a typical indices. 6 raised to power 7, this is a typical indices. What is on top is called the exponent. That is the power. We call it exponent or power, while the down one is called what? The base. I want you to be conversant with these two terms because we'll be using them as we progress mastering the laws that govern the operation of indices. So if you take a look at the down example here, we have 6 raised to power 7. And if you look critically, you discover 7 is our power, is our what? Exponent, while 6 is our what? Is our base. Are we together, class? Thank you. Then if we move further, we'll look at various laws of guided indices. The laws are highlighted as you can see on the frame. We have the multiplication law, the division law, the power law, the product power law, the zero index law, the negative index law, the root power law, and the fractional index law. Let's begin with the first law, which I term law 1, which is a multiplication law. The law simply states that when 2 or more indices are multiplying each other and the bases are equal, all the student need to do is to pick a base and add the exponent, or add what we call the power. Here is an illustration. As we can see, we have 5 raised to power 2 times 5 raised to power 1 times 5 raised to power 3. As the law clearly stipulates, we pick a base, which is simply 5. Then we add the powers. We sum the exponent, which is simply 2 plus 1 plus what? 3. Then eventually we have 5 raised to power what? 6. Are we together, class? So this is as simple as the law states. We pick one of the base. Since the bases are equal, we pick a base. Then we sum all the indices. This law is applicable provided the bases are what? Equal. Then we move to the second law, which is the division law. Supposing we are given this expression, and here we are having division here. It changes the whole equation. How? Because the division law simply states when indices, 1 or 2 or more indices are dividing each other or one another in this context, the law simply states we pick a base and we subtract the index, we subtract the exponent, we subtract the power. By illustrating this, we simply resolve this. We simply say 2. Because the bases are equal, we pick 5. So it will be minus 1 minus what? 3. Are we together, class? It will now be what? 5 raised to power what? Minus 1. But I would help you solve how we convert this minus 1 to a normal index when we get to what we call negative index law. But if you look at what we have on the slide, we have 5 raised to power 4 divided by 5 raised to power 2. We simply pick the common base, which is what? 5. Then we have what? 4 minus 2, which is the exponent. We have 5 raised to power 2. Then we move further into the next law, which we call the power law. This law simply states that when an indices is raised to a power, a particular number, and is raised to a power another number, the power is distributed across the base. For instance, if we have x raised to power a and is raised to power b, the answer is simply x raised to power what? ab. The two power will multiply. For instance, let me illustrate this by showing you an equation, an expression over here. If we have 4 raised to power 3 and raised to power 2, then what we have is simply 4 raised to power 3 times 2. That will be 4 raised to power 6, our final answer. So these are some of the laws that we are building. As you will see subsequently, when we'll be given an example which we are going to combine this law and see how they operate. Then if we move to our next slide, we have what we call product power law. It is a situation where the power is distributed across the bases in the bracket. What does this law state? It simply states that when a product of different bases are being raised to a certain power, maybe in bracket, or the power is distributed of each factors in the bracket. What am I trying to say? Supposing we have x and y raised to power a. The law simply states that since the bases are unequal, this power will be distributed across this. This simply means that we have x raised to power a and y raised to power a. Are we together, class? So we can look at this. If we are to look at illustration, we simply say maybe 3 times 2 raised to power 2. This is simply 3 raised to power 2 times 2 raised to power 2. Are we together, class? So with this, you discover that the product power law simply reflects itself. What we have in the formula is the same thing we are operationalizing. Then we move to the next slide, which is the zero index law. It simply states that any number that is raised to power 0 must certainly be 1. Just give me some seconds. Let me wipe up the board for proper illustration. As we progress, the zero index law simply states any value, any number or any parameter that is being raised to power 0 will surely be 1. That is, x raised to power 0 is 1. If we say 6 raised to power 0 is 1. 1000 raised to power 0 is also certainly what? 1. Then we move to the next law, which is negative index law. The law simply states that whenever an indices is being raised to a negative index, maybe minus raised to power minus something, to remove that minus, we simply find the reciprocal of the base. What do I mean by the reciprocal of the base? We simply say 1 all over the base raised to power, that power without minus. What am I trying to say here is simple. Let me illustrate what I'm trying to say on the board. Supposing we have x raised to power minus 2. According to the law, we simply reflect, excuse me please. According to the law, we simply remove this negative index by finding the reciprocal. What is reciprocal? 1 all over x. Then we put the 2 without any exponent. So similarly, if we have 3 raised to power minus 2, to find the reciprocal is what? 1 over 3, while is what? Raised to power 2. So these are some of the laws that we have been examining. So as we move further, we have what we call root power law. Root power law is very interesting because this is where most of the examination questions will begin to flow. Most of your TMAs will begin to flow. Because the root power law is very, very similar to the next one, which is a corollary of it. What do I mean by a corollary? Something that is derived from the previous one on the same principle, on the same reasoning. The root power law simply states that whenever an indices is being raised to a power of a fraction, we find the nth root of that fraction. That is to say, the law simply states when a number is raised to a fractional index whose numerator is 1, The result is finding the nth root of the denominator, and it can be mathematically denoted as illustrated on the board. Let's see what the law states. Let's say x raised to power 1 all over 2 and x raised to power 1 all over 3. These are illustration. But if it is x raised to power 1 all over n, so we simply find the nth root of x. We simply find the square root of x, while here we find the third root of what? X. As you can see, the denominator of the index is the root, respectively. So similarly, if we are to operationalize this, we simply say 3 or we say 4 raised to power 1 all over 2. This is equals to square root of what? 4, which is what? 2. If we say 27 raised to power 1 all over 3, this is cube root of what? 27, which is equals to what? 3. That is the root power law. But the next law we are looking at is called fractional index law. A situation where the numerator here is not 1, but is of a value. It's of a value. So the law simply states, let's understand what the law means. The law simply says when a number is raised to a fractional index, whose numerator is more than 1, the result is finding the nth root, the denominator, and using the base as a factor by power of the what? The numerator. By the power of the numerator. This is what we are simply trying to say. Assuming what we have here. Assuming what we have here is x raised to power a over b. We simply find the b root of x, as you know previously, but it will not be raised to power a. So using the same reasoning, if we have 3 raised to power 2 all over 3, if we have 3, if we have 27 raised to power 2 over 3. So what we find is the third root of 27, then we raise it to power of 2. And the third root of 27 is what? 3, which is 3 raised to power 2. And 3 raised to power 2 is what? 9. Are we together, class? So as you can see, we are building the laws gradually. Then here, the next section is combination of rules. When we say combination of rules, what are we trying to achieve? We are trying to achieve what we call the totality of the rules. Rule 1, which is the multiplication law, division law, power law, negative law, zero index law, all the laws will be combined together. For instance, look at this illustration here that clearly shows the combination of rules. We have 9 raised to power minus 1 over 2 all over 27 raised to power 2 over 3. Common sense simply states, to remove this, remember, we find the reciprocal, the negative index law. So we find square root of what? 9. Are we together? We find, please students, you should be careful with this minus sign. Here, first, 1 all over 9 raised to power 1 all over 2. Let's go step at a step. We still have our division here. This is third root of what? 27 raised to power of 2. Then here we have 1 all over 9. This becomes the square root of 9. If you like, you put the 2. If you like, you don't put the 2. All over. The third root of 27 is what? 3 raised to power 2. Then similarly, if we proceed this way, this is 1 all over 3 all over what we have here is 9. Then similarly, this is 1 all over 3. We can write it like dividing by what? 9. And when you are dividing two fractions, because the 9 is over 1, there is what we call inversion. This becomes 1 over 3 times 9 all over what? 1. To convert the division to multiplication, we invert. 1 comes up. Are we together? 1 comes up, 9 comes down. Then eventually, we will be having 1 all over 27, as we can see on the board. But if you get on your own leisure time, you can try this combination of rules. We have 1 all over 27 minus 1 all over 3 times 16, 1 all over 4 times 8 minus 2 over 3. No, I think we should proceed and solve this. This that we have here can be rewritten. Let's first of all remove the minus. This is 1 all over, open bracket, 1 over 27 raised to power 1 all over 3. We've removed the negative index. Times, this is the 4th root of 16. Times, remove the bracket, 1 all over 8 raised to power 2 over 3. We've removed the negative by finding the reciprocal. We proceed. 1 all over, we'll find the cube root of 1 and 27 times 4th root of 16 is 2 times 1 all over cube root of what? 8 raised to power 2. You remember this law? The root, the power, 4th root, 1 all over. How do we get 1 here? Because to remove this negative index, we do 1. 1 all over this. You can see it step by step. Then the minus sign disappears, remaining 1 over 3. The 4th root of 16 is simply 2. Removing this minus sign, we'll find the reciprocal and we'll repeat it without the negative sign. And this means that the 3rd root of 8 raised to power 2. Then this is 1 all over. The cube root of 1 is 1. The cube root of 27 is 3 times 2 times 1 all over. The cube root of 8 is 2. Then raised to power 2. Are we together? Then this is 1 all over 1 over 3 times 2 times 1 all over 4. Assuming we move to the next section of the board. To complete this is quite easy. This is 1 divided by 1 all over 3 times 2 times 1 all over 4. Here is 1 times 3 over 1 times 2 times 1 all over 4. Here we have 6 all over 4. And you know 6 is too big for 4 to carry. So what do we have? We have a 1 whole number, 2 all over 4. No? Excuse me. 4 here, 1. So 6, 2 here, 3. 2 here, 2. 1 whole number, 1 all over 2. That's our final answer. However, there are many also illustration and example in the study material on your LMX that you can go through. But the application of all these laws into equation is called exponential equation. What is exponential equation? An equation, either the base, which is the down number, or the index is unknown. For instance, if I simply say 5 raised to power x equals to 25. This is a typical exponential equation. And in solving exponential equation, which we normally apply in mathematics or finance under time value of money compounding, in solving exponential equation, the objective is to make either the basis equal or the index equal. So this is 5 raised to power x, and 25 is also 5 raised to power 2. 5 raised to power 2 gives 25. If you verify with your calculator, since the bases are equal, you cancel the base. Then x equals to what? 2. That is the simple process of solving exponential equation. So let's examine another equation, another example of exponential equation. We have 5 x plus 1 equals to 625 equals to 625. Are we together, class? 625 is a factor of 5. However, this is 5 x plus 1 raised to power 5. 5 raised to power 3, 5 raised to power 2, 25 raised to power 3, 125, raised to power 4 should be 625. Then, since the bases are equal, we cancel. We have x plus 1 equals to 4, then equals to 4 minus 1, then x equals to 3. So these are all examples of exponential equations. There are other examples also that students can also, like the example C, the one displayed on the frame there. We have various examples that students can solve. That sums up first part of the study session. But before we proceed further, I would like you to look at C part of the study session. The C part of the equation that we just finished solving. This C part formed one of our previous examination questions. And because of that, it attracted my interest. We have 9 raised to power 2x plus 1 equals to 81 x minus 2 divided by 3 raised to power x. You can see that this is far somehow complex than this. But let's begin to apply the law of logarithm, the law of indices. If you look at it here, 81 can be expressed in the lowest base of 3. 9 can be expressed in the lowest base of 3. So this is simply 3 raised to power 2 is 9. 3 raised to power 2 is 9. Multiplying 2x plus 1 equals to 3 raised to power 4 is 81. Multiplying x minus 2 divided by 3 raised to power x. This is already in base of 3. So you can see we've expressed everything in base of 3. So this is simply 3. You begin to expand the bracket because according to the power law, it's multiply both the power at the top multiply each other. This is 4x plus 2, which is equals to 3 raised to power 4x minus 8 all over 3 raised to power x. And as you can see, the bases are the same. But let's ensure before cancelling, we have 1 3 here, we have 1 3 here before we can cancel out. This is 3 raised to power 4x plus 2 equals to 3. Since these are dividing each other, this is 4x minus 8. Then we subtract the index. This 4x minus 8 is subtracting x. Then we continue. This is 3, 4x plus 2, which is equals to 3 raised to power 4x minus x minus 8. Let me clear it here so that we can proceed. Class, are you following? Let me just take it from beginning. Here we have 9, 81, 3. They are all common factors of 3 because 3 is the lowest base of 81. 3 is the lowest base of 9. 9 is 3 raised to power 2. 81 is 3 raised to power 4. Now, this is 3. So there is no point in breaking this down because this is the lowest base, 3 raised to power x. 81 becomes 3 raised to power 4. This is another way of saying this is 81 multiplied by this, raised to power multiplied by that. This is 9, 3 raised to power 2, and the power is still multiplying this. So 2 times 2, 4x, 2 times this. This is 2. 4x minus 8. Are we together, class? Then we proceed by applying law of division. When we divide, we subtract the index. So this is 4x minus x. So what we have here is simply 3 raised to power 4x plus 2 equals to 3 raised to power, now 4x minus 1x, which is what? 3x minus 8. So now we can cancel the base. This is 4x plus 2 equals to, are we together, class? This is 3x minus 8. Then this is 4x. When 3 is crossing the inequality sign, it becomes negative. That is the new visa required to enter the new country, which is 3x. This is minus 8. When this cross, it become what? Minus 2. So we have x equals to what? Minus 10, our final answer. So as you can see, class, what we've been doing so far, we've been applying indices into an equation form. And if I want to take you back, let's quickly go through the laws again. The first law, we say the multiplication law. When two or more bases are multiplying each other or one another, we simply pick the common base and sum the index. Then law 2, which is the division law. When two or more bases, more indices are multiplying each other, we pick a common base and we subtract the index. As you can see the illustration in the frame. The third law, which is the power law. When a particular indices that is already raised to a power number is also raised to power another number, both powers has to multiply each other. That is why you discover what we have on the frame is 7 raised to power 2, all bracket then raised to power 3. Then 2 times 3 is 6. So the final result is 7 raised to power 6. Similarly, also, there is what you call product power law. A situation where we have two different set of bases or more. Whenever the two different set of bases are all raised to power a particular exponent, that exponent is distributed across the bases. That is where we have xy, all bracket raised to power a. It will now result in x raised to power a, y raised to power a. That is where we have 2 times 3, all bracket raised to power 2. We have 2 raised to power 2, 3 raised to power 2, according to the law. Then the zero index law. This law simply states any expression, any value, any number that is raised to power 0 becomes 1. So the one we have on the frame is 4 raised to power 0, which is 1. We can have 20 raised to power 0 is 1. Y raised to power 0 is 1. Anything raised to power 0 is what? 1. Then the next law we have is what you call negative index law. Whenever any indices is being raised to power a negative value on top, the power, the exponent is negative. What do? To remove the negative, we find a reciprocal of the indexes and repeat the indices in the denominator without the negative value. What am I trying to say? The reciprocal simply means 1 all over that indices, and put the power on the indices without the negative value as indicated on the frame. We have 5 raised to power minus 2, then it's transmuted into 1 over 5. To remove the negative, it becomes 1 over 5 raised to power 2. Then the next law we have is what we call root power law. Whenever indices are expressed in the power whose denominator is a value but the numerator is 1. That is, when the index are in fractions, by implication we use the denominator of the index to find the nth root. Since it's raised to power of 1, we just leave it like that. So we have 4 raised to power 1 over 2, we find square root of 4, which is 2. 9 raised to power 1 over 2, 9 raised to power 1 over 3, we find the third root of 9, which is it should be 27, which is 3. Then we have fractional index. This is a situation where the numerator and the denominator of the index are in numbers, no 1. That is x raised to power a over b. It will become b root of bx all square raised to power a. Here we have 27 raised to power 2 over 3 based on what we have on the frame. So first of all, we find the third root of 27, which is 3. Then we now raise it to power of 2, which is 9. Similarly, we have 16 raised to power 3 all over 4. We find the fourth root of 16, which is 2. Then we raise it to power 3, which is 8. Are we together, class? Then the last is combination of rules. The combination of rules, as you can see from the expression, we have the first one, the second one, the third one, which you can see the solution beside them. So at this junction, I want to pause so that you can go home, digest it, learn what we've done, revise it. Remember, mathematics is simply the science of practice. The more you practice, the more you understand. So I would like to submit this lecture in the name of God, the most gracious, the most merciful. Thank you, and God bless.